This video is about the literacy words for algebra. Let's start off with term. A term is numbers and letters joined together but separated by pluses and minuses. So if I have a look here, I'm looking for the pluses and minuses because that separates terms. So you can see there's 1, 2, 3, 4, 5 of those. So each of these is a term. 2x squared is a term, plus 4x squared is a term, minus 2x cubed is a term, plus 3x is a term, minus 4 is a term, and plus 2 is a term. You notice that the sign, the plus, goes with the following term. Next thing is like terms. Like terms have exactly the same letters. Now, up here, these two are like, because 2x really means 2xx, and 4x really means 4xx. They've got exactly the same letters. XX and XX are the same, or x squared and x squared is the same. X cubed is not like these ones. It is really this is really minus 2xxx. This is not like because it only has a single x. These don't have x's. So these two are like terms, but also minus 4 and plus 2 are also like terms. The next thing is pronumerals, variables, and unknowns. They are all the letters that you see in algebra. So up here we've got x is actually our only pronumeral, variable, or unknown. They're called pronumerals because it's a place to store numbers. They're called variables because they can change. And they're called unknown because we don't really know what they are yet. The next word is coefficient. A coefficient is a number in front of the letters. It doesn't always have to be in front, but we write it that way because it's easy to understand. So when I've got 2x squared, the 2 is the coefficient. The x is the variable, and there's two variables. There's xx in this term here. So the 2 is the coefficient. In plus 4x squared, 4 is the coefficient. In minus 2x cubed, minus 2 is the coefficient. In the number 2, there is no coefficient because there's no letters in that term. A constant is a term without any letters. So minus 4 and plus 2 are both constants, and they're called constants because they don't change, because they don't have any letters to change. In algebra, when you simplify, you make the expression less complicated. In this example here, I can change it by gathering some like terms. 2x squared and 4x squared both have exactly the same letters, so I can combine them. I've got 2 of these and 4 of these, which means I've got 6 of them if I put them together. With the x cubed, the minus 2x cubed, and the plus 3x, they cannot be added or subtracted to anything else because the letters are not exactly the same. This one is xxx, this one is x, this is x squared, that's x squared. The only two that can go together are these two because they have exactly the same letters. So I need to keep 2x squared, or the minus 2x cubed, sorry, and I need to keep the 3x because I can't combine them with anything else. When I look at the numbers on the end, minus 4 and plus 2, they are both just numbers. So like numbers, we can put them together and add or subtract. In this case, minus 4 plus 2 makes minus 2. This expression has been simplified. Instead of having 1, 2, 3, 4, 5, 6 terms, 1, 2, 3, 4 is simpler. Substitution is when you replace the letter with a number. In this example here, I'm going to substitute by letting x equal 1. That means I'm going to get 6 multiplied by x squared, which is 1. Putting in brackets is a safe way of not mucking up your positives and negatives. Subtract 2 times x cubed plus 3 times x minus 2. Now here's a good example of why the brackets are good. If I put the bracket in here, I can see that the 1 is squared, not the 6, just the 1. If I look here, the 1 is cubed, not the 2. So I'm going to be, and here, this is really 3 times 1. Remember, in between this 3 and this x is a multiply. In between this 2 and this x is a multiply. In between the 6 and the x squared is a multiply. So these are really multiply as well. Putting the brackets means that you're less likely to make that mistake. And if I didn't put the brackets at this point, this number here would look like 31 instead of 3 times 1. So when you substitute, you then keep going until you can get an answer, which is what evaluate means. So I'm going to do 6 times 1 squared. Now 1 squared is 1, so 6 times 1 is 6. 1 cubed is 1. So minus 2 times 1 is minus 2. 3 times 1 is 3. And I've still got the minus 2 on the end. So let's have a look. We've got 6 minus 2 is 4, plus 3 is 7, minus 2 is 5. So I have evaluated and got an answer of 5 for this expression when I have substituted x equals 1. So the expression, let x equal 1, substitute is this part, evaluate is this part, finding the answer. On this page I have an expression and an equation. They almost look the same, except that the equation has to have the equal sign. So this top thing at the top is called an expression. It's got lots of terms added or subtracted together. The one underneath is an equation because it's got the equal sign. In an equation you actually have two expressions. You have this side, which is an expression, and that side, which is also an expression. But an equation has to have equals. When you factorise, that means splitting something up into two multiples or more. So example, 12 factorises into 4 times 3. It also factorises into 2 times 2 times 3, and we would say that's better. If I've got also x squared plus 5x plus 6, I can actually factorise that into x plus 3, x plus 2. Now that doesn't look like it's something multiplied, but remember, of course, in here is a hidden multiplication sign. So basically, this bracket is multiplied by that, and these are called the factors of this expression. 2, 2 and 3 are factors of 12, x plus 3 and x plus 2 are factors of x squared plus 5x plus 6. We often do also what's called the highest common factor. That's just the biggest factor that divides into two things. So here's an expression, and if I was looking to see what the highest common factor is, I need to find out the numbers and the x's, the most that I can actually take out as the highest common factor. So looking at the numbers 5 and 10, 5 goes into both of those. So I'm going to put 5 here. And if I look at the x's, there's an x in each term. So if I take an x out and put it out the front, then for the first term I'll need an x just to make it work, and a 2 for the second term. And what I do is I just check that it works. 5x multiplied by x is 5x squared. 5x times 2 is 10x. 5x is the highest common factor for this expression.